Welcome to Lesson 7 in Unit 16, Pinball Wizards. In this lesson, students will work to answer the question, how can we use force and magnetism to build a pinball machine with tricks? In this lesson, students combine everything they've learned about force and motion to solve the anchoring problem. They define the problem, apply what they've learned about force, and engage in the rest of the engineering design cycle to develop, build, and test a solution to the problem. Students figure out that their pinball machines must meet the criteria and constraints to be successful, and that the machines can be designed in a variety of ways that use force to make the pinball move. Students make connections to the storyline by using force and magnetism to design a game that will solve the problem. There are several opportunities for ELA cross-curricular connections throughout the lesson. You can look for specific standard connections in the Unit 16 Teacher Guide. This lesson will take approximately 5 to 6 days to complete. To begin the Engage portion, you'll display the letter from the Carnival Committee from Lesson 1. You'll also show the engineering design cycle along with some questions. You'll review parts of a pinball machine and ask questions about the problem they're trying to solve. Then you'll revisit the driving question board and add any new questions and highlight others connected to the learning goals of this lesson by calling attention to questions about how to make a pinball machine. You'll discuss the criteria necessary to create a successful solution to the problem, and you'll talk about the constraints students will have to work within. During the discussion, you can post the criteria vocabulary card. You'll show students the materials they have available for their pinball machines and discuss the constraints they need to work within to solve the problem. You can then display and discuss the constraints vocabulary card. You'll use the Pinball Wizards student journal page to review the criteria and constraints. You'll write these on the board so students can refer to them as they are building. For the Explore portion, you'll put students in engineering teams of 4. They will remain in these teams for the rest of the unit. You'll discuss the value of developing and testing models, then they can work in their groups to talk about and draw their ideas. You'll set up the Pinball Wizards engineering supplies to have ready for students. There is a teacher tutorial showing the setup linked in the teacher guide. The detailed procedure for this activity can be found in the teacher guide as well. Students will use the supplies to develop and test their pinball machines. Pause the video here to review the needed supplies for this activity. Before students can begin constructing their models, you'll discuss the steps they'll take to solve the problem, as well as how they'll record their data and discuss ideas with their teams. You'll then invite students to work in their groups and use the materials to develop pinball machines. You'll circulate while students are working to build their models, to provide support in their creation of designs that meet the criteria and constraints of the project. Once their models are created, teams will use the pinballs to test their machines. You'll work with teams to develop a fair test strategy for their data collection. Students will record their observations as data in Step 5 of the Pinball Wizards student journal page. For the Explain portion, you'll bring the class together and lead a discussion about students' observations from their findings from their pinball machine testing. You'll use the provided questions to guide your discussion around the question, how can we use force and magnetism to build a pinball machine with tricks? The goal of this class discussion is for teams to share how their tests identified any failure points or difficulties, and how their designs meet the criteria for success. There is no summary chart for this lesson's discussion. For the Elaborate portion, you can provide engineering teams time to make any final tweaks to their pinball games. If time allows, you'll have students use Step 7 in their Pinball Wizards student journal page to redesign or revise their pinball machine. These pages and their final models will be their summative performance task. For the Evaluate portion, you'll hold a class carnival to have students present and play their games. Students can use their Pinball Wizards student journal pages as they present and play. While students play other games, you'll have them use their Compare Solutions student journal pages to compare the other team's solutions. Students can also use the 3-5 MySci Peer Feedback Table Tent to help guide their discussions. Use the assessment tracker and the summative performance rubric to evaluate students on their final game projects. This summative assessment and rubric covers standards and elements from across the unit, not just this lesson. You'll then invite students to review what they've learned about forces, magnetism, and their time as engineers. The goal of this discussion is for teams to revisit the learning throughout the unit and wrap up the unit. You can use your summary charts from throughout the unit to help guide this discussion. To support student sense-making across the unit, orient them back to the driving question board. Ask, did we answer any of the questions on our driving question board? Are there any questions we haven't answered? Try to wrap up any final questions on the driving question board before the end of the unit. Have students complete the sections 2 and 3 summative assessments. By the end of this lesson, students will have defined the problem they are trying to solve using criteria and constraints for a solution, developed, built, and tested their pinball machines using fair test strategies, and used cause and effect to explain how the final pinball machine uses unbalanced forces to solve the problem. This is the last lesson in the unit. For the optional Extend portion, you can invite other classrooms over to play in the Force and Motion Carnival, or send your engineering teams as ambassadors with their games to other classrooms to play. Students should explain how their design uses force and magnetism to make the pinball move, but don't have them give away any tricks. You'll then have students work in their engineering teams or independently to complete the Pinball Wizards writing extension opportunity in their student journals. They will make a claim about how their games solve the problem and use evidence from forces and motion in the unit to support their claim. For more information about this unit, visit myscipartners.com.